Welcome, students, on my series of discussions of the chapter laws of motion. We have discussed force, we have discussed momentum, we have discussed even spring force, gravitational force, different types of forces. Okay, and today we are going to do some numericals. Okay, involving spring force. In fact, we are going to discuss a little bit about the friction also. Okay, so it comes actually under the chapter laws of motion, and as you know, my name is Amarnath. So let us discuss. Okay, from second law of motion also. Okay, you can say that it is a continuation of my that one last class only. Okay, so let us start discussing some question. Okay, first question. We start our discussions with a question on the today. So, say on a horizontal table, okay. Remember, up till now, we are not taking any friction on the table, but later we are going to take friction also, okay. Say this is a force, okay. And say this is 2 kg, say this is 3 kg, say this is 5 kg, okay. Name of this block is say A, B, C, okay. Say I have applied a force 20 Newton. So first my question is calculate the acceleration of all the three blocks. Okay. First question. And second question, find the tension on the string. Say this string is 1. On the string 1. Find the tension on the string 2. Okay. So you see, first you try to understand how I proceeded. Okay. And I am going to give you almost similar question. And that question you will definitely solve. Just try to solve according to my way only. Okay. You see. First of all, you understand here. See, they are connected by thread. Okay. Thread. And thread are tight. Okay? Thread are seem to be tight only. Okay. So it means if this 5 kg goes by say 1 millimeter, so this also must be going by 1 millimeter only. Otherwise, this thread will be torn out or it will be slacked. Okay. Similarly, this must be going with the same displacement only. Okay. It means their velocity must be same. Everyone's velocity must be same. Their velocity cannot be different. That means their acceleration also same. It means acceleration of
Excuse me, sir.
okay.
Sir, is the acceleration 2?
Acceleration
2.
2. Where is the acceleration 2?
No, sir, I have calculated the acceleration.
Okay. Acha, already. Yes, that is correct. Acceleration is 2. Yes. So acceleration of this also will be same and this also will be same only. Okay. So if acceleration is same, so theoretically we can take as a single object. So say I'm taking this is a single object. Okay. I'm assuming this is a single object. So it means here I can directly apply the formula F equal to that one ma. Well, so F external net F external equal to net mass into acceleration. So you see for the whole system there is no force from the back side, na? So only right side there is a force that is 20 and total mass is equal to 2 plus 3 plus 5. Okay, and total acceleration is a, so acceleration is found out to be 20 by 10. So acceleration is 2. unit is meter per second square. SI unit of acceleration. So first question's answer is found. Now find the string tension in the string 1. So for that actually you have to draw the free body diagram of this part, okay? So if I draw it, you see, say this is the 2 kg object and here is the string. So the string will pull it, okay? That is tension 1 only. There is no force in from the back, okay? There may be friction on the surface, but in the question it is not mentioned. So it means we have to take the friction is 0, okay? So only rightward direction force is there. Again, you apply the force equal to ma. So, but this time force is only T1. But mass is 2. But acceleration already I have shown that acceleration of all the three must be same only, the value. So that is 2. So it means tension on the thread is 4. Okay. Remember, means this thread is pulling the 2 kg with to 4 Newton only. Okay, 4 Newton. But the same thread will pull the 3 kg leftward only. Remember, the same thread pull the object B leftward only, okay? So if you draw the free body diagram of 3 kg now, okay, that is actually for 2 kg. But now if you draw the free body diagram of 3 kg means B, so you see this is B, this is B, this is 3 kg. So here the tension will be leftward because tension always pulls. Tension will pull the 3 kg leftward. But this thread will pull it rightward. This is T2. Okay. This thread is second thread. Okay. This is the first thread. Tension 2. Okay. 2. So here and acceleration is in this direction. So direction of acceleration is rightward. So you should take the rightward force as positive. Okay. So it means plus T2 minus T1 equal to, because you know that this is net F net equal to, because F net equal to mass into acceleration. No? You mass into acceleration. But this time we have two forces. So one is T2 and another is minus T1. Must be equal to 3 into 2. But you know the value of T1 already you have calculated now. That is 4. So which is equal to 6. So it means T2 equal to 10 Newton. Okay. So if you calculate the free body diagram of 5 kg also, now you are going to get the same answer only. Okay. You can check only, but not required. Okay. For 5 kg, because we have already calculated all the answers. Now. This is already calculated, this is calculated, this is calculated. But still, if you want to check it, you can calculate. This is 5. So rightward is what? 20. Leftward is what? T2. Because in this thread, it is T2 only, na? Because this is the second thread. So it is rightward force is 20, leftward force is T2. Must be equal to mass into acceleration. Acceleration is 2 only. F equal to ma. So it means 20 minus 10 equal to T2. So 10 equal to T2. It means T2 equal to 10. So from this side, from this also, we have found T2 as 10. And for calculating 3 kg also, I have found T2 equal to 10. Okay. So you please try to understand and give a recap of it. Okay. I'm going to change the question. Okay. I'm going to just change the value and okay. Everything will be
Excuse
remaining
me,
same.
sir.
Okay. Tell
Sir,
me.
I have a doubt.
Go ahead.
Sir, I have a doubt that why did you take T1 as minus?
In case of 2 kg, 5 T1 is minus. Yes.
Why, sir?
You see, because force is a vector quantity. Huh? Force is a vector. Vector means where direction is very important. Okay. Here, F equal to ma. A force is also vector. Acceleration is also vector. So in vector, actually, if rightward is positive, if the leftward must be negative. Always. Okay. So here I have taken T2 is positive. So T2 is positive. Nothing is written means positive. So T1 must be negative. Okay. Here also I have taken t2 negative, you see. T2 I have taken negative, okay. 20 I have taken positive. Means I have assumed that right direction is positive, left direction is negative, okay. Because in vector actually, in vector quantity, you cannot directly add it, okay.
Okay, sir.
Okay.
So,
Okay.
so why is the acceleration equal for all the masses?
Again, that is a very good question. Actually, that is called a constraint relation. Constraint means majburi. Constraint का मतलब मजबूरी, constraint relation. Actually, in your cases, in most of the cases, you will find that, in all of the cases, you will find that acceleration of all is same only. You see how? I have already told you. Say here actually, the problem is that string will always be tight. String will always be tight. Okay, it will not be loose, and it will not be slacked, as well as it will not be torn. Okay, it cannot breaks up. Okay, so what does it mean? If the 5 kg goes by say something, say 3 millimeter, example I am giving 3 millimeter, so this also must be going by 3 millimeter only. If it goes with more velocity, more displacement, the string will be slacked. But if it goes with some less velocity or less displacement, the string will be torn out. Are you getting or not? It means their
Yes, sir.
displacement means displacement for all the object must be same. Now you see displacement by time is called velocity. So it means velocity of all the object must be same because they are connected by a thread. And secondly, velocity divided by time is called acceleration. It means they must have the same acceleration. In all or most of the cases, you will find acceleration same only. I am going to give you one more example. Say this is a pulley. Okay. Say this is a thread. This is a thread. Okay. Same thread. Say this is a mass. Okay. So this is also another mass. So now you see, if the mass falls down by 1 millimeter, it must go by 1 millimeter up. Otherwise, the thread will be slacked or it will be torn out. Okay. So in that case also, their acceleration will be actually magnitude of acceleration will be same. Okay. But direction will be different. If one fall down, other must go up. But value will be same. Okay. In this case also, I'll do this type of problem also.
Sir, I have a doubt that, like right now, if we can say that, like, what if like the thread was of unequal, it was unequal length, that like
No.
one of them was really small and one of them was really big.
No. In
So
this
will
case,
that be the
no, what you are asking, still I could not understand the question. You want where it will be unequal. Okay.
No. I'm saying that what if like the thread between the three boxes that are connecting them, what if they were like unequal? They were like of unequal length.
Ah.
Like one of the thread, like just take thread one, it was like really small, and like in thread two, it was like really big. So will that be
No. I have not told about the length. Length does not matter it at all. Okay. The length does not matter. Length may be anything. The length of the thread does not matter. Just what I am saying, try to understand it. What I am saying, try to understand it. I told you, say this is the surface, okay? Say this one is a block, okay? Thread, this one is a block. This thread may be long, it does not matter. But my question is, if you pull it, if the block goes to this position, so this will come to this position, yes or no? If it goes by X,
yes, sir.
this is also must go by X. This also must be going by X only, okay? And it happens it happens simultaneously. So X by T means velocity. It means its velocity must be equal to its velocity and its velocity. Again, velocity by time, it is nothing but acceleration. It means each acceleration and each acceleration all must be same because they are connected by same thread. Okay. Okay, calculate the acceleration of all the three blocks and find the tension on the string 1, find the tension on the string 2. Mass is 1 kg, 3 kg, and 6 kg. So, constraint relation is that all must have the same acceleration, okay? Same acceleration. So, as they are having the same acceleration, we can take as a combined object, okay? Combined object means 1 plus 3 plus 6. So, rightward only the external force is 40 Newton. There is no force from the back side, okay? So now you can use the formula for F equal to ma. So F is 40 and the mass is, yes, 10 a. So acceleration is 4 meter per second square. Very good. Excellent, excellent, excellent. Now we talk about A, okay, for A. So this is 1 kg. Only one external force is there, which is T1, tension on the first thread. So external force is T1. There is no force from the backside. So we do not require to write anything. So T1 must be equal to mass into acceleration. So it means T1 equal to 4 only, 4 Newton. Well, then for B. So B is 3 kg. So right direction it is tension 2. Left direction it is tension 1. So right directional force minus left directional equal to mass into acceleration. Actually, remember, always my suggestion is that always the direction in which acceleration is there, you take it as positive, okay? Say acceleration is right direction, so you take it as positive. Right direction is positive, okay? If acceleration is left direction, then you can take left direction is positive, okay? No issue. Then it will be easier for you, nothing else. So tension T1 minus T1 value is 4 only. And acceleration is 4, no? Acceleration is 4. So it is 12. So it means T2 is equal to 16 Newton, okay? Enough, okay?
Excuse me, sir.
Uh,
Sir, I
okay.
first calculated the 6 kg. For T2, I calculated the 6 kg. So force
Okay.
is equal to mass into acceleration. So mass is 6 kg and acceleration is 4. So I got 24.
But that is the net force, na? Here T2 is also there. So it should be actually 40 minus T2 must be equal to 6 into 4, no? So 40
Okay, sir.
minus T2 equal to 24. It means 40 minus 24 equal to T2. It means it is 6, 1. So it is T2. So it means T2 equal to 16. Okay. So in both the
Okay.
way, answer should be same only. Okay. Understood now? Okay. Can I rub all these things or you need some time?
Yes, sir.
Okay.
Yes, sir, you can. Yes.
Okay. Let us try some another type of question, okay? Say this is a block, okay? Say this is 5 kg. And this is another block. Say this is 2 kg. And I have applied a force F equal to say 14 Newton, okay? Now my question is that find the acceleration of both the blocks. Okay. First point. And second point, find the normal reaction. This is called normal force also. Okay. Find the normal reaction or normal force. Okay. Between the two blocks. Okay. That is the two question. And remember, in this question, you learn it. How I am approaching. Doubt arises, ask me several times. Okay. You don't approach, don't start doing now. You just try to understand. Ask me whatever question it comes to your mind. Okay. But in the next question, you just apply your all talent. Okay. Because I'm going to give a similar question then. See, here, what is the majburiya? What is the constraint you see? If I push the 5 kg block, so 2 kg block also will go, okay, along with it. So it means if 5 kg block goes by 10 meter, so 2 kg block also will be going by 10 meter only. I'm not giving any jhatka, okay, I'm not giving any impulse. Then of course, and I am also not talking about the friction. Friction is not there. So it means they will go together only, okay. So it means in this situation also acceleration of 2 kg and acceleration of 5 kg both are same. Clear? If I draw the free body diagram, you see, this is 5 kg. So here it will be the force 14 and here it will be the normal reaction given by 2 kg on 5 kg. Because remember, normal reaction always a pushing force. It is not pulling, it is always pushing. Similarly, for 2 kg, so this will be the normal reaction. Remember, this normal reaction and this normal reaction, both are same only, but value same only, but direction opposite, okay? Now you see, as they have the same acceleration, so for the two bodies, if I draw together, because they have the same acceleration, so it will be 5 plus 2, okay? And only the external force will be 14 Newton. But I know that F equal to ma. F is 14, A is 7, acceleration is A. So from that I get acceleration is 2 meter per second square. 14 by 2. So acceleration is found. Now first part is over. But in the second question, find the normal reaction between the two blocks. Means either you calculate this, find the normal reaction, or for this, find the normal reaction. Okay? You will get the same answer only. Say for 2 kg I am doing, for 2 kg. So for 2 kg, you see, only the normal reaction is the external force. I know F equal to ma. F is n only. Mass is 2, but acceleration is also 2 only, okay? At this place. So 2. So it means normal reaction is 4 Newton. Similarly, if you do it for 5 kg, you are going to get the same answer only, okay? But for confirmation only you can do. Otherwise, you should not do, okay? Achha, in which direction it is accelerating? Rightward, na? So now you tell me whether you are going to write 14 minus n or n minus 14. What do you think?
14 minus n.
14 minus n, because 14 is rightward. So rightward is plus. Normal reaction is leftward, so negative. Must be equal to 5 into A. A is 2 already. So it means 14 minus 10 equal to n. So 4 equal to n. It equal to 4. So you see, this way also you are getting the same answer. Okay? So this is a 3 kg object, 7 kg object. I have applied a force 30 Newton. Find the acceleration of both 3 kg and 7 kg block. It will be same only, okay? A3, A7, both will be same. Find the normal reaction between 3 kg. You have already done. I have not completed writing only. 3 kg and 7 kg block. The acceleration unit is not Newton, okay? Acceleration unit is meter per second square, okay? If you cannot write, no need to worry about it. I understand, okay? Because writing is difficult little bit. Meter per second square you cannot write. I understand. Okay, let me also. So if I take both as together, so total mass will be 3 and 7. So it is 30 Newton. So it means F equal to NA. So A equal to 3 meter per second square. Now if I draw the free body diagram, this is 3 kg. So it will be F, it will be N. If it is 7 kg, for 7 kg, actually only one normal reaction is there, okay? So I think it will be better, it will be easier to solve, okay? So N equal to what? 7 into A. So N equal to 7 into 3. 7 into 3. So it means N equal to 21 Newton. If you for the sake of confirmation, if you want to solve for this also, then also you are going to get same answer. F minus 3, because F is rightward, N is leftward. Okay. Rightward is taken as positive because I know acceleration is rightward. So F minus 3 equal to mass into acceleration. So F minus 3 equal to 9. Huh? Something is acceleration 3, na? 21. Okay. 3. That is 30, na? F is 30. Okay. F is net force equal to so F minus N equal to 3 into A. F is 30 minus N, 3 into 3. So it means 30 minus 9 equal to N. So 21 equal to N. N equal to 21 into. Okay? Good. Good. Meter per second square, huh? Unit. Actually, velocity is meter per second, but acceleration is meter per second square. Meter per second square. Because velocity by time, na? Velocity is meter per second. And again 1 second. Because velocity by time, na? So meter per second by second means meter per second square. Anyway, let us do a question from spring, okay? Let us change the type. So this is one spring, okay? Remember, if you are not said, spring is said to be a massless spring, okay? Mass of the spring is always 0. If they are not said anything, so always you will take that mass of the spring is 0. Now what I do, I extend an object, okay? The spring constant is 20 Newton per meter. Okay, that K value is given in the question. Now what I do, I extend, just suspended an object of 10 kg. So now my question is, what is the extension of the spring? Okay, what is the extension from the natural length? So what is the question? Find the extension of the spring of spring constant spring constant 20 Newton per meter when a 10 kg load is suspended vertically from it. Okay, please write the question first. See, I know that when, say, this is the ceiling, one spring is there. So if mass is not loaded, spring will be at the natural length only. But if I load the mass, no, that on the hook, if I place the mass, the spring will elongate. Say now the mass is at this position, okay, it is stationary. So it means the force on it is zero now, okay. So force on the 10 kg block is zero. But I know that downward force is 100 Newton only, na? Gravity. And upward force is always K into X, because spring force is always K into X. We know spring force value is always K into X. So it means what? It means it is also an equilibrium. It is also a case of equilibrium. Equilibrium means net force zero. So if I take downward force is positive plus 100 and upward force automatically will be negative. One will be positive, other will be negative because they are having opposite direction. Then equal to mass into acceleration, but acceleration is zero. It is waiting, na? It is stationary. So from that, what I get? 100 equal to K into X. That X is elongation only, nothing else. So 100, K value is 20. So it means X equal to 5. Okay. All are in SI, so it will be 5 meter only. If you have any queries, any doubts, ask me, because I am going to give you similar question for the coming situation. Is it okay? Are you getting the situation? F equal to Kx. Spring force is always K into X. That K part is called spring constant. That value will be given in the question, or otherwise other values will be given. We need to find out the K value. Okay. Can I respond? I am not getting any voice. Nitish, can I go to the next question?
Yes, sir.
Okay. Similar question I am going to give, nothing else. Find the spring constant K of a horizontal spring whose natural length is 1 meter and when an external force pulls one end, its length becomes 1.01 meter. Remember, I am not giving the exactly same question. I am just little bit that one. When an external force F is equal 10 Newton. Okay, that part also you should write. F equal to 10 Newton pulls one end of its length. One of its end, its length becomes 1.01 meter. It means situation is like this. Say this is the spring, okay? Now its length is 1 meter. But when the same spring is pulled by a force F equal to 10 Newton, its length becomes 1.01 meter, okay? Now this is the situation. So you please try it, okay? Formula is same only, equilibrium is same only, okay? Say this point is at equilibrium, this point is at equilibrium. Rightward force must be equal to leftward force, like this, okay? Okay, if I draw the free body diagram of this point, okay? So the point is in equilibrium, so rightward force is 10 Newton and leftward the spring will pull it, na? So it will be Kx. But remember, x is equal to actually final length minus initial length, na? So final length is 1.01, initial length is 1. So x is nothing but 0.01, okay? So that is x actually. So now you see rightward force minus leftward force equal to 0. So it means 10 equal to kx. So 10 equal to k into 0.01. So k equal to what? 10 by 0.01. It means k equal to what? 10 into 100. So it means k equal to 1000. 0.01 means 1 by 100. Huh? So that 100 will go up by the rules. And SI unit of that are Newton per meter. Okay. Okay. On that note, actually, I am going to wind up today's class. And remember, just immediately after my class, you just do the that one. Okay. That quiz. Okay. I have already given you. And tomorrow also again, you may get tomorrow also you are going to get one quiz. Okay, if I get some time, I'll manage. I'll just get on frame the quizzes based on today's topic only. Okay, spring will be there, normal reaction will be there, tension will be there. Okay, tension, spring, and normal reaction. Okay, on that you are going to get numerical. Okay, so on that note, I am going to give bye bye to all of you. See you on my next class.
Bye, sir.
Okay, bye
Bye, sir. Thank
bye
you.
bye
Bye, sir.
bye bye.